I actually call this project Quebra-Cabeça. My wife's from Brazil, I speak Portuguese, but I figured I would use the English term for the talk. But how did I get here? Like, where did I begin? Actually, a lot of similarities to some of the other talks that were given today, including Eli's. Yeah, those actually aren't pictures of ones we personally owned, because that's what I found on my phone. But those models are things I had. We actually did have one or two original 128Ks and one or two 512s. We had two of one of the other, the original Macintosh models, and a bunch of the classics and SCs and things like that. Beyond many, many others. My dad would bring computers home from universities and government agencies and things that they would be getting rid of the old computers, be bringing in new ones, especially back in the 90s where every year a new computer was actually improved from the last year, not like these days where you can have a 15-year-old laptop and it works just fine. The computers, though, didn't always completely work, right? You'd have this one and that one and you'd have to change parts, and so that's how my brother and I learned how computers work growing up, is we'd take them apart, we'd swap them out, and my dad brought home used landfill bound computers on purpose so we wouldn't take apart his. Not that he would mind that particularly, but as a lawyer working from home, like if his computer didn't work, we didn't make money, right? So it was important to him to give us the opportunity to learn. And not just us, but everybody. My dad, sorry. Sorry, I thought I was ready to talk about this. My dad's mission was to make computers available to all students, and he worked with. He worked with Boy Scouts groups and with schools, and we tried to get computers to these places for students to be able to use them, to take them apart and learn from them. And because he wanted to let everybody have access, he had, okay, that didn't work. I'll do it from here. This is on the wrong screen. Which way am I have to go? Okay, so when I say lots of old computers, wait a second. Just wait a few more seconds. They're gonna move over in just a minute here. Maybe I need to skip a little bit, but okay. So this is another part. Notice some iMacs back there. Some of you might recognize the iMacs. So it's not just computers in the shed, but it's mostly. And so yeah, growing up we had to deal with this mess, but there was a reason for it. Right, my dad wanted and this was the good stuff. Okay, so my dad made this part up in the top of this building. This is a farm building. We called it the shed. I don't know what the official term would actually be, but it's meant for tractors and things like that. And my dad built this little upper level for the good stuff. Notice a pile of 2GSs back there, a color classic in the top. Those gray and white ones in the corner there. Which one's the little laser pointer? I don't know which button does the laser. Green one? There we go. Those are Duo docks. So there was a time where Apple made these laptops that you'd slide them into the dock. So you'd have all your stuff plugged into that. And you just slide the laptop in and everything would pop up and you slide the laptop out. Didn't last very long. So this was the good stuff they had set aside. And even in the good stuff, we had probably 100 computers. So this obviously is not obtainable for most people. My brother is currently, G4 iMac. That thing was awesome. This is not something that most people can do, right? And even should do. So my dad passed away about 8 years ago now. And my brother is still dealing with trying to pack this stuff up. This video is actually somebody that he found who came up from Portland and hauled away a trailer full of it. And what you saw there was after they had loaded half of the stuff into the trailer, after my brother's already spent years working on this. So that's, I think, just kind of the best way to really get a feel for where I came from and why I'm here. Okay, let's go ahead and close that up. So I came from this very small community where we had all these computers, and that was my backyard. I had 48K dial-up growing up, and that was good stuff because not long before I was born, apparently we still had party lines. And so my dad said we had good dial-up because the lines were brand new because they had just moved them from party lines to real individual per house phone lines. And so that's why we had good dial-up modems. I did not see faster speeds until I was in college. So growing up, I did not have access to the internet. Not only was it new, but it wasn't really available for me. When YouTube finally came around, I would have let a 5-minute video load for half an hour before I could even watch it, right? Then I spent a few years in Brazil. I didn't mention this here, but I served a mission in Brazil. I was there for a couple years. My wife's from there. I'm very well aware that not everyone has access to all the tools that we all have. Not everyone has access to all the resources that we all have. Growing up, I spent all the time I could learning everything I possibly could about computers, taking them apart, putting them together. I didn't have a library with good books to go down to and get the books, right? The closest library was half an hour away, and it was a town of 2,000 people. We didn't have computing stuff. I just trying to figure it out all on my own. And even then, I won awards in high school because I was just curious and trying to figure it out. So I'm working on something. Yes, I'm a computer science major, currently a firmware engineer. I've met a few people. I do currently work at Micron as a firmware engineer. This is what I'm working on and why I'm here now. I'm currently working on something that I think will help give people access to the sort of thing that I had and meet some needs I see in the education space for computer science. As a computer science major who meant to be an electronical engineering major, that was its whole other story. I had to do classes online because I was living in Brazil, and I ended up in computer science and realizing along the way that, I want to know how computers work, and I got enough out of the computer science classes that I was able to figure out how transistors turn into gates and gates turn into digital logic that do all the stuff in the computer. Like CPUs was my fascination for many years. Like how does sand turn into something that can process that? Like that 3D image, if I go into KiCad, I will later in the demo, if I go into KiCad, I could just drag that around in real time and it's generating this thing, and sand did that. That was just blew my mind. Like, well, at first I didn't even know it came from silicon. I didn't know what it did. What made a CPU work and how it worked. So I was curious enough to dig. Some people are curious enough to dig and don't know where to look, like I did. It took me years to find these things, and I want to help find, provide resources that will make it easier for them to dig. And some aren't quite as curious or just need a little more guidance. And so the idea here, I'm trying to keep this short so we can get on to the KiCad part. But the idea is to have a computer that students in a computer science major can fully understand. Many times I wished I grew up old enough in the 80s, as a 90s child myself, grew up in the 80s where you'd have your Apple II, you'd have your Commodore 64 or your Atari, and you'd open, you'd do your basic, and you just turn it on and it started working immediately. I had some of that experience because my dad had old computers, but for some reason I never actually got into programming them until I was in college. I was always more interested in the hardware. Nowadays, what kids have is completely inaccessible. There's no way to program your phone from your phone. Like even Android, you can't really, it's just not a thing. Right? You can't program your phone from your phone. You can't know how it works. You can't even open it most of the time. Like someone here was saying how like he's on screen replacement 5, I think, in his family. Like he buys phones specifically that have screen replacements. That is not the common thing that people do. And so working on this platform that will make it easier for students to understand, because the computer is simple. It's simple like 8-bit or 16-bit from a long time ago, but it's made for education so that it's an architecture that people can actually understand. The documentation's provided. I was going to take a class using the Raspberry Pi. That year the 3 came out. I bought the 3 because it's 64-bit. Wow. The class wouldn't let me use it because they were using the old Pi 2. The documentation wasn't available for 3 because no one had reverse engineered it yet. There was not good enough documentation from Raspberry Pi, the corporation, with lots of employees and money, for a class to actually use that documentation in the class. They had to wait for the community to come up with the documentation. Raspberry Pi is small and cheap. It is not simple. It is a full-blown computer with all of the features. So something simple that I can provide documentation, students and teachers can use. I'm looking for help in talking about ideas, what's actually valuable to have for the first version. Plan would be to have like your sophomore level one, and then a junior level one, a senior level one. We like advance through the years of technology and complexity with multiple versions. That's the idea. But while I'm developing this, while I'm trying to come up with it, I came up with some problems. I too am from a software background, as I mentioned in the last slide. I've always had interest in hardware, but I never actually went to school for it. I did take a few classes when I got the chance, and I've picked up a lot along the way as a firmware engineer, but it's not my main, my major. It's not my main experience. So how do I start? Start with small things. I wanted to start with small things and pieces of this thing. Like one of the ideas also would be, this is something that you can expand by plugging in little modules. Well, what better than to use an industry standard? Some of you might be aware of Digilent. I just remind myself to speak slower because I'm not entirely sure I can fill 40 minutes, so I was going to speak nice and slow. And here I am just going through the races. The connectors on the edges here are just your standard 12-pin, 2-row, 6-pin connectors. Digilent calls it PMOD. They have these PMOD connectors. They make these little boards that are used in education that you can plug in VGA and sensors and all sorts of things, and you've got an FPGA in the middle, and you can program it to work with those. And so very, very flexible, well supported. This PMOD specification has been around like 15 years or something. And just so happens that Digilent lives just up the street from me. So I actually know people who work there. The idea, I think, is great. You have things that you can plug in, play. But in PMOD, all these things are different sizes. You've got one that's this big and that big and this big, and one's 2 wide and one's 1 wide, and some things are 2 wide even though it could have been 1 wide, because you can have them as 1 row 6 or you can have them as 2 row 12. And like the VGA one is 2 1x6s instead of 1 2x6. And I just, right, it kind of evolved naturally over time, and it doesn't all make perfect sense. And for something that I want people to be able to kind of piece together modules onto, and while I'm developing, kind of break it into pieces that I can develop smaller pieces, I thought of something that I'm calling quebra-cabeça, or puzzle pieces, where I'll come up with little pieces that are all the same size, and I can swap them out. If I have this piece, I'm like, well, I want this other one, I can swap it out. I don't have to redevelop the whole computer. I don't have to redevelop the whole kit. Just that one little board, I can swap out that board, and that'll be easier and cheaper. And and you'll notice also like there's a USB-C port up there. Yeah, someone made a comment during lunch that I completely agree with. USB-C with USB 2 is the way to go. USB 3, super complicated. USB-C, the port, excellent. I want to be able to plug it into a student's laptop, program it from the laptop, power it from the laptop, have a nice plug-and-play compatibility there. And of course, I'm also here to learn from all of you, get feedback, meet people. I've already met a few professors, handed out my card, because I'd like to know what are the needs you see with your students. I mentioned that I want to help students understand, I kind of glossed over that a little too quickly. Computer science fundamentals. Why did I mention fundamentals? It took me years to dig to the bottom of a lot of things because we're at a state now in the industry where computer science is so complicated. We built on the shoulders of giants on top of other giants on top of other giants. It's very difficult to understand the whole architecture of anything. This computer I will not lift up. It's plugged in. If I may, this one, it's also plugged in. Okay, my phone. So these things are very complicated. Your phone, like, how can you turn it off? Yeah, when you press the button, it turns the little light on saying, look, you need to charge me. It's not actually off. There's always a little system in there. There's so many little systems in there that are actually always running, always doing something. DFU mode, like you press a certain combination of buttons and it will do something even though it's off. These things are so complicated. They have so many computers inside of the computers that how is a student supposed to wrap their head around all that? So I mentioned the idea of taking steps through time and complexity. If you give a student something that's simple enough, you can let them get straight to the point of that class without having to understand the whole computer first. That's my idea. That's the concept. If it's an operating system class, why do you have to spend 3 weeks going through all the weeds of ARM architecture to get to operating system? You want the 3 weeks of ARM architecture, but maybe not right away, maybe not in the beginning, maybe that comes later. So that's the ideas there. So where I'm going with this, I'm starting up a little thing I'm calling Appaloosa Computing. Appaloosa refers to a horse, but it's also the region of the Palouse. The Appaloosa and the Palouse are what inspired the name. And so I'm trying to support the education community, and I want everything to be open source. That also is for, Arduino. You can, if you want to, download specifications and build your own boards. Nothing's stopping you. I want to be able to do the same sort of thing. And so KiCad was an obvious choice for designing things because open source community, open source hardware. I want to be able to design things that will interoperate. I can make this thing, if you want to buy mine, great, buy someone else's, that part of the module, make your own to expand things. I want it to be an ecosystem that, obviously it won't be the first ecosystem in this realm, but I haven't seen anything quite like the way I want to do it. And so, and also, want to work on courses and help people learn the computer science and engineering topics to help upcoming engineers. Someone made a comment earlier about people retiring because they've been in it for so long, and that is another reason of concern that I have. We have people with lots of years of experience, very wise. And what happens when they all retire? They're retiring out of technology that is so much more complex than what they entered into. New engineers today are entering into a field that's more complex than ever before, and they're expected to just get up to speed. I feel like we need to be able to ramp them up to speed. And especially with companies, I don't know in the electronical industry, but in software, there's been a long-running joke about needing 5 years of experience in a language that's only existed for 2 years. It's very common these days for companies to go, we want juniors to have 5 years of experience and seniors to have 20, and everything's so complicated, you need people to have all this experience to be able to do anything. Well, how do we help them? Well, Pullman, home of WSU, just a few miles from Idaho State University, I want to be able to work with students and bring them on board and say, okay, work with me, help me develop the course, help me develop these things, and learn this experience. Learn this for yourself, starting from the basics. And so that brings us to prototyping, which is kind of the main purpose of this talk. The idea came from, as I'm trying to develop this computer, like I was saying before, I need these parts that I can kind of test. Like, okay, this single computer, the single board computer is not that complex, but it has multiple parts on it, and I really want to make sure I get each part right. So let's split it out into multiple bits. And And from some recent experience I had at Micron as well, I realized that it's great to have these things that you can plug into each other. But someone set up this, like literally this big, like 4 foot by 2 foot thing, chunk of aluminum with a bunch of little holes in it. And he clamped down a bunch of dev boards and he wired them up to each other. And everyone's saying that the board that he clamped everything to was more expensive than all the electronics on top of it. And that's how he could keep everything in place. And that was still better and cheaper than just, buying the first rev of this board that he's working on. And I thought there has to be a better way to do it, because the idea of prototyping is, you're doing some pathfinding, right? You're doing feasibility and risk assessment. You want to be quick and easy to iterate on. You don't want this big, expensive board to set up everything up on. You're going to learn from the experience. And, if something doesn't work, you can quickly and easily replace things. There was one part, there was a dev kit that broke, and I was trying to replace it. And I had to find all the right wires, make sure when I unplugged everything, it came back and I plugged it in the right way. Everything's going to fry and let all the magic smoke out. And so, of course, prototyping helps reduce cost. Now, as not a veteran of many years, these are the thoughts that I have about prototyping. I'm actually curious if anyone wants to throw out any other quick thoughts about why they prototype, why they develop quick, small boards. Anything else you want to add real quick?
Proof of concept for management?
Proof of concept, yes. It's a great point. That I actually was going to mention something about that on the next slide, so great point. Anyone else? It's actually ironic you mentioned that, because the board I was just talking about is exactly that. It was supposed to be a proof of concept for a project.
So I'll throw another reason, which is so that you can develop the firmware or software when you don't have the actual hardware.
I'm ashamed of myself for not putting that up there. I'm a firmware engineer that keeps complaining about the electronic engineer. It's a constant problem where, by the time we get the board, they've been done with it for 3 months. Electrical does everything in the schematics, then layout gets it for like 2 months, and then Sierra, then the board house gets it for 2 months, and then we get it like 5 months later, and by the time we found a problem, they're like, well, we're on 2 more projects after that. We don't know what you're talking about. So yes, that is a problem. So prototyping, what are some things that might be seen as problems? Now, some of the things I put up here, I don't actually see as problems. They're just things I've heard. Now, this one, might be a good reason why you don't need to. Like, if you've been doing this for a long time and you really know how that part works, like you've already prototyped that part of the board before, you can just throw it on there, then you might skip prototyping. This is a counterpoint to management. Sometimes management might say, well, it's a waste of time and money to work on the prototype. Why don't you just make the real thing? Yeah, let's not do that. I've seen prototypes go into development like, oh yeah, that's good. It's like, no, that's the prototype. That does not work properly. No, it's good enough. Spent money on it. Let's reuse it, right? And then you might just be revising an old product, and so you really don't need a new prototype for that one. It's just revision of the old one. So what are some ways of doing it? Well, there's the classic breadboard. Got my little breadboard here. This I went ahead and put together to show my kids kind of how it works. And I've got my little Arduino, I have my breadboard, I have my 9-volt battery, and you can see it hooked up there. I can flip the little switches, I get my hex out on the 7-segment display. Proof of concept, I was able to write my firmware for the Arduino, because that was the main thing I want to make sure I got right. Like, I'm writing some code, I want to make sure my code's right, just throw things out on the breadboard. Worked great. You can do it in-house. It's quick and easy to set up. It's easy to tear down. And so there are a lot of benefits to it. There can be some problems with breadboards too. Like, it's easy to tear down on accident. I'm actually very surprised this survived my backpack. Like, all the resistors are still standing up. I don't know how that happened. You know better than me, there are issues with breadboards as well. You can't do everything with them. So the next thing you might do is grab a perf board. I gave up before I finished this thing. I got 2 of 8 wires wired up, and I was like, no, I'm not doing that. But this is a great way. This can be, it resolves some of the issues with your breadboard. You know, it's also in-house. It's relatively quick to put together, but it stays together, right? Everything's soldered down, it stays together, and you can kind of wire it up however you want. Some issues are that you have to know how to solder. I went ahead and decided to do this one so I could show my son, like, hey, this is how soldering works. Like half an hour later, he's like, I'm bored. It's like, yeah, I know, but when you see it working, it's going to make it worth it. Then he left, and then about 2 hours later, I was like, okay, well, here's it partially working. Obviously, I'm not as experienced as some of the technicians I know, but it's still a good learning experience for me, and you know, it's part of the experience. This shouldn't have been as hard as it was. It's just been a long time since I'd done that much soldering, and I thought it'd be a little easier. So don't know where he went, but the gentleman with the hat mentioned, yeah, it is hard to estimate how long things will take. But perf board is a great option too. So what's the next level? What am I here to talk about? It's the idea of making your custom PCB, right? The pièce de résistance. I don't speak French. This is what I'm trying to get to, right? I threw this together in KiCad. Honestly, it took me less time to learn KiCad and lay out this board than it did to try and make this perf board. So, what I'm here to tell you, and you probably already know this, of course, is sometimes it's great to just go straight to one of these. For me, it was easier to do than the perf board. Sierra or JLPCB or all these others, you can often just get them pre-populated when you order them. You don't even have to build it yourself at home. And in my case, I would have preferred to just order up one that was ready. I just didn't have time for the conference, because I could have been off doing something else. Yeah, it might take a few days to arrive, but I could be working on something else instead of, you know, doing up a perf board. Now, you might say, but it'll take time to set these up, right? Like, I have to make a new project every time. I have to start everything over. So enter KiCad templates. There are already a few templates that are in there. We've got Arduinos. We have some other things that, like the BeagleBone and the Edgeberry cartridge. So they already have some templates in KiCad. I said the wrong name for years until I learned it yesterday that it is KiCad. Apologies. There are already some templates in there that you can use that make it easy to work with custom, common designs. So, got my Arduino here. If you want to make a shield for this, very unfortunate that they got the spacing wrong on that header. I was trying to wire up this thing for the breadboard, and I put a header on this perf board, and I went to plug it in. It's like, oh, that's right. I can't just plug my perf board into my Arduino. So common designs are already in there. They also make it really easy to make your own. Went back too far. So it's also actually really easy to make your own templates. And so that's where, what time am I supposed to, because I got started a little late. What time am I supposed to be?
Be done when you're done.
Okay. I got a little demo here. So I'm going to bring up KiCad now. And make sure it's on the right screen. So if you start a new project, there is a new project from template option. For me, it's Command T. So here's the templates that we're talking about before. And you'll notice that there's this user templates option. So these user templates, I've already got 3 in here, and here's the path. Like, all you really need to do is create a new project in that path, and it'll show up here. So I'm just going to start with this first one. So that board I showed a picture of in the design is based off this template. If I hit OK, it's going to start a new one. It's going to ask me where to put it. I can put it over here and talk, and or KiCon. Let's give it a quick name, right? And so, a couple things to keep in mind because it's just a project that got put in that folder, when you make a template, when you make something from this template, it just copies it over with everything inside, including footprints and symbols. So we got footprints here and symbols in here that I made custom. The PMOD connector is just a 2x6 connector, but it has special names on the pins and things like that. And so I wanted to make my own. I made my own symbols and footprint for, the footprint was just so that I could link the right footprint to that header, because the PMOD's always going to be that footprint. And they got copied in too. They're part of the local project, so they got brought in when I made my little project. And so this is going to make it really easy to make little boards that I can plug into my computer, because every time I want to make a new one of those, I can just pull up this template and it will be the right size. Because not only does the schematic come over and got brought up on the wrong screen. Let me, I was afraid of that. Okay, I got my schematic. It already has my header and socket. I can go into my PCB. And so everything in here, everything about the project comes in. So your page settings are, I forgot to fill them in here, but you know, the title and company would have been in there. Anything you have in here, like custom net classes, text variables, everything that was in the original project would come over. So if you want to put your company name in your template, it will bring in to every single one of your projects that you work on. And now I got to bring over PCB editor, right? And this was the key for me, since I'm working on something that I want to be a puzzle piece where everything will just fit in. I want the size to be right every time. I'm going to lay things out differently, so I debated not even putting the traces on this template, but I just wanted to show you that yes, everything comes over. This board will be the exact size I want because this edge cut came over from my template. So now if I lay everything out inside this, everything's fine. But what if it doesn't fit? What if it doesn't fit on this one? Well, that's why I have my other template. Right, I've got a 4x1, right? So say I want more connectors. So I'm working on something that's going to be, 8 bits of data, 16 bits of address, and 8 bits from some other stuff. The PMOD connector has 12 pins, but 2 are ground, 2 are VCCs, so I only have 8 bits for data. So for my little computer, I want 4 PMODs, right? Or connectors. So I'll hit OK on this one. I think I just put that inside the other folder on accident, but we'll ignore that. Right, this one has more space. I have more space in here. I can lay more things out. So I can make multiple templates. Well, actually, maybe I want a 2x2. So actually, what I could do, just delete those. I'm going to override that lock. This side, this. I don't have graphics selected. I'm going to resize this. I now know what it was like for him during the training yesterday, having to look off to the screen while doing this. It is disorienting. Why am I not seeing what I... Yeah, this is what I want. I want it to be, it's 0.8 inches for one, plus 0.7 for next. There we go. Bring up, oh, okay, we will ignore the zone. Let's just make, so I already had a ground zone in here as well, just to show that the zones come over nicely as well. We're going to ignore that for a moment because it would be a little bit more of a pain to, I had to custom shape on the VCC zone to go around all the pins, so.
It'll update the zones automatically if you press B.
No, yes, but I had to redraw it.
No, it'll stay within the edge.
No, well, since we brought it up, it's these little nubs here on the edge that I'm talking about. Yeah. Yeah, the zone's right, I just didn't, but yeah, that works. So Anyway, now this one is a 2x, right? And it's only 2 tall instead of 4. And that is most of what I had to do. If I went back to the schematic, I could fix that up here. Delete these. I don't have all items selected. I'd want to renumber some things and stuff like that, but just to get the idea across. This one that I called test 2, if I come over to here, actually stuck it in. No. Where did I put it? Oh, there it is. Okay, so this is the one that we're talking about. If I put it in the 9.0 template folder, it's now here in the template folder along the other ones. If I hit Command T, user templates, it is now in here. It has the same name as the other one because I haven't updated its metadata, but I just saved a KiCad project, put it in the templates folder, and now I have a new template that is a 2x instead of 4. And there it is. So this is a new project based on that one. And that's all it took to make the template, was just couple minutes to save it and put it in the right spot. The only other things you'll really want to do is you'll come into metadata. This icon shows up in there. This picture, I would want to replace this picture, but I have that here referenced in info HTML. And I'll just come in here and say, this isn't a 4 high, this is a 2 high. I would replace this image and change my title. And now when I go to the user templates, 2x1 12 mode, 12-pin PMOD busboard. So making a template is really quick and easy. If you have something that you want to reuse, design rules, there's some things you learned from the Sierra talk that, there are rules you want to turn on for all your boards, that everything you send to Sierra, you can make a template for everything you send to Sierra that has all these design rules built in. All of that will be brought over. Quick and easy to make. And there is, quick shout out to the team that works on documentation. Graham, I saw him earlier. Thank you again. QR code takes you right to the documentation that explains how to do exactly what I just showed you. That's where I learned it from. It's great. It's there. Everything's reusable. And I plan on getting the sizes all for what I'm working on, I plan on getting a few more prototypes built, and then once I kind of have a feeling for how wide I actually want things, what's wide enough to have enough space, but not so wide that I'm just wasting space. I plan on making some templates, putting them up on GitLab or GitHub, making them available for other people to use, and make their own things as well. I'm planning on making the thing that I showed. Yeah, that was, okay, the animations were a bad idea. You live and you learn. Anyway, this is the first thing, like I said, I plan on making. Want to make a few other things like that, and then make some templates available for other people to use, because I'd like feedback. I'd like other people to get involved and let me know what they think. Let me know what you want to make. I was going to, given time, I was thinking about doing asking you guys for some ideas to throw open a board real quick, but I think we'll call that good enough. Thanks for all the fish, and have a great evening. Any questions? I know I didn't explain everything that well.
So, do you have? I assume you've kind of done surveys of the current landscape for these sorts of reduced complexity single board computers. Do you have things that you feel like should be different from similarly from similar single board computers? I assume I saw in the image looked like you have a CPU on there and a couple of I/O level shifters maybe.
Yes.
And so is that choice then a direct result coming from what you're seeing in other sort of modular systems? Ones I'm thinking of are like the Seed Studios has their small modular system. We saw another modular system at KiCon Europe for the Open Skunk Works has another kind of not the same but similar kind of overlapping. So wondering what your survey of that landscape was.
Of course. So obviously it would be impossible to survey all possibilities because I would have spent all my time just looking at everything that exists. I eventually had to get to the point where it's like, okay, I've seen enough to know that there's enough people trying to do similar things that obviously there's a need to fill with them, but also none of them are quite like what I'm trying to do, so I think there's still space for what I'm working on. Some things that I was inspired by was, some of Digilent's boards, obviously because I'm using the PMod. The main thing I'm going for, I'm going for something that I can target multiple levels of the education system, where starting with the computer science, I wanted to make something that was 80s simple. You can look at boards from a computer in the 80s. I forgot to bring mine with me, but I had one from a Mac Classic. You can look at that board and you don't even need a schematic. You can just look at it and you know what everything does because you look up the part numbers, the level shifters and all that, and you can figure it out. That didn't last very long. Many computers that people make these days that are simple as an 80s computer just reuse 80s computer parts, which means you're going to have problems sourcing parts. One of the tips that got mentioned. I actually considered that. I was like, okay, well, if I want a computer that's as simple as an 80s computer, use the 68K. Love that chip. 60K, wonderful. You can't get them. You can get some and then they'll be out.
Are you kidding? You have thousands of them in the Macs in your
So some of those are PowerPC, and they're multiple generations. You'd have to harvest them from the boards, but yes, touche. Right, and so sourcing parts would be an issue. And so right now where I ended up with is I'm actually using an FPGA that you can put a simple CPU on an FPGA that will be RISC-V doesn't go down to 8 or 16-bit, and so I'm thinking about, I don't know what else is already out there, or if we make something up ourselves, that's room for feedback. But if you make just something very simple that lets them power it on and they can write some code for it and it works. So that's one of the main differences from things like your Feather and your Seed and whatever, where you have an MCU. MCUs are small and cheap. No air quotes on those. They are small and cheap. They're small and cheap, but they're not simple. You've got 5 SPI buses and 8 I2C, and you got all these things they have to set up when you turn them on, and that defeats the purpose of give this to a computer science student, not a robotics student, not an EE. They don't know what SPI is. They just want to write some code that makes Hello World show up on the screen, right? So start with something that I can configure to be super simple for them, and then I realized, well, if it's got FPGAs on it, maybe we could hand this to EE students too, where you're doing your digital logic, and you could have one class, you write all the digital logic to make the computer, and then you hand it to your CS students, and they write the code that gets put on top of it. Or, I give it to CS students already loaded, preloaded from the factory. So it can address multiple students. And so that's kind of where I landed right now, where it's something that's configurable so students of different areas can use it depending on what's already loaded on it. You want your CPU to run better because now you want it to be out of order or superscale or something, throw that in your Verilog and you re-upload it, and now you have a better CPU, and now you can go up a level. Like, okay, the first computer didn't have all these fancy tricks. Now that you have an MMU or superscaler, now you have to worry about these problems in your code. And so they can level up the computer and then upgrade their software to follow it, instead of being thrown in the deep end of, you've got an MMU and you have multiple threads and all that. And so that's kind of what informed the decision of how, and then modularity as well. Well, USB didn't exist way back when. It's complicated. Start with a PS2 port, something simple. But if you want USB, you can plug it in on the end. You can add that and then write the software for it. So that answer the question? No?
Thanks, Reed. I had a question too. Thanks so much for your talk. It was really nice. I really like, obviously, the educational focus. I know we talked earlier. And you started to answer it at the end there. But I just wanted to hear a little bit more about, where are you going to target maybe first for this curriculum development and the goals? I know you're going to work with maybe a couple schools up there. But which maybe classes or what aspects of classes do you really see this starting to work very well with?
Of course. The first one that I considered and targeted was the idea of the operating system, because that's where your CS student will actually get to where they touch the hardware close enough that the complexity of the hardware affects what they're learning and doing. I don't remember my operating system class terribly well, so I don't remember what all we did, but we did do some things with scheduling and memory management and some stuff like that. And I remember thinking, we're writing this code, but I'm running it on my Mac that I'm just kind of running this dummy code, just kind of get the idea of the algorithm, but I don't actually see it doing anything because it's not really, I'm not really writing a kernel, I'm not really writing an operating system. So my idea is if you have something that's that simple, you're going to get, okay, here's your 10, 15 pages of data sheet, this is your memory map, write this, it will load on using an SD card or programmer over USB-C, something like that, some details to work out. And then every line of code that you write will actually run on that and actually output from its VGA port or, emulated VGA back to your CPU. I don't know. They're again, details to figure out. Then, so the operating system is between hardware and software, so I thought it was a good place to start. But you could also use it for like an algorithms class where you want to visualize your algorithms. On something this fast, it doesn't matter if you bubble sort or quick sort. It'll be done in a millisecond. But if you put it on some old slow CPU that's running on an FPGA, your algorithm will make it a lot slower, right? So you can stick it on some simple computer, put it on there, have a little visual output, and oh, that algorithm is really slow on this computer, and you can actually see it, you can feel it. So that's another class I think might start with. But I'm also open for what professors think, like, oh, that would be really good for this class, something that I can customize and make fit the needs of that class.
Awesome. I think your ideas are great. I look forward to seeing them.
Thank you.
Okay, thank you, Reed.
Thank you all.